All right, what's up? What's up? So, last time we met, we talked about unified threat management appliances and web security gateways. Now we're going to talk about VPN. And this is going to have to be kind of quick because I think it's raining outside and I don't want my iPhone to get messy or get broken. So I'm going to have to get right to the point here. But make sure you take notes because this is a lot to cover. So VPN, virtual private networks, is exactly what it sounds like. You're essentially you're establishing a secure connection over an insecure medium known as the internet. So you're able to connect to an internal resource on a local area network through this encrypted connection. Now, there are actually two kinds of VPNs, all right? So there's host-to-site and site-to-site. The host-to-site is also known as a remote access VPN, and this is where you've got somebody either in a hotel lobby or an airport, or maybe they're connecting to an open hotspot in a coffee shop. Maybe they're at home, they're working that way. But they're essentially opening up a laptop or something like that, firing up a VPN client and connecting over the internet, over the public internet, to a secure resource on the corporate LAN. And this is the typical way that it's done. Now you might see, for example, if you're a hacker and you fired up Kali Linux and you've got aircrack-ng running, you're trying to sniff packets, you're going to see the data going across the wire, but it's going to be completely scrambled. It's encrypted, so you're not going to be able to do anything with it. So it's pretty secure. Now the site-to-site VPN connections are also another option, and that's where you have two sites. So maybe the headquarters are connected to a remote office, maybe a satellite office, and it's a permanent VPN connection that's established over the internet. That's really the main difference there. Now, when these connections are set up, there's really two kinds of connection types. So there is the IPSec version. It uses IP security, and there's also the version that uses your browser. So that would be HTTPS, which means that it uses basically SSL, secure sockets layer, and TLS, transport layer security, to encrypt the data stream. Now, the good thing about VPN is that it doesn't just encrypt the browser. It doesn't just encrypt communications that are originating from your browser, but it encrypts all communication coming from your machine to the destination, which is a corporate LAN. So this is like a really big deal. So it means that your email communications are encrypted. Anything else that you do in that LAN is encrypted. So how does it do this encryption? How does this even work? Well, there's actually two options. There's two methods. In IPSec, in the IP security standard, it uses the Encapsulating Security Payload, ESP, which has a protocol ID of 50. And it uses this to provide confidentiality so that people can't easily view private data. It provides integrity so that the data is not going to be changed, and also authentication. So it authenticates the connecting clients, and it creates what's known as a security association, an SA, between the client that's connecting to the VPN concentrator and the VPN concentrator itself. And by the way, a VPN concentrator is really just a device that concentrates multiple connections, but it's not, today in 2017, you're not going to find standalone VPN concentrators. Usually this functionality is built into a unified threat management appliance. So you might have an appliance that's a firewall, and it does content filtering, and it's also a VPN concentrator. Just wanted to let you know about that in case you were wondering. Now, the other thing that's really interesting, so you've got the ESP, the Encapsulating Security Payload. You also have the authentication header. And this is what's responsible for mutually authenticating each side. So the client authenticates to the VPN concentrator, the concentrator authenticates to the client. This is all done through the authentication header, which has a protocol ID of 51. Now, these protocol IDs that I'm bringing up are different from port numbers. These aren't ports. IPSec, VPN doesn't use port numbers in that way. The only time port numbers really come into play is when you're using the Internet Key Exchange, IKE, which is part of the setup process. It uses port 500 when it's trying to establish a secure conversation between the client and the VPN concentrator. And that's what those security associations are, which I mentioned earlier, the SAs. Hope that makes sense. My phone's getting really wet, so I'm trying to get to the point. So one of the disadvantages of IPSec, though, for VPN is that it's not very NAT friendly. So it doesn't do well with network address translation because the headers have to be modified, and it breaks the the secure conversation. So a lot of people will use the other version, the SSL/TLS version of VPN. Now there's two modes that you also need to be aware of. So there's transport mode and tunneling mode. So the transport mode, that's usually used on a corporate LAN, and that's where the payload is encrypted, but not the header. In tunneling mode, both the header and the payload are encrypted, and that's what's used in traditional remote access VPN networks. So I think I've covered everything that you need to know there. If I know I went kind of fast, if you might want to rewind and get some more data, more information about that. It's raining out here. I need to put this phone away. Tomorrow we're going to talk about NIPS. I know that sounds kind of weird, but we're going to talk about NIPS and NIDS. It's not what you think it is. And just go ahead and leave a comment. Tell me what you think about this video. Thumb it up. Make sure you subscribe because I've got more content coming your way, and we're going to pass this test. All right. So I'll see you tomorrow. Bye.